Hi, my name is Jason Harlow. Welcome to my V Office Hour. I'd like to go over Physics 131H1S from Winter 2011. Term Test 1, Version 1. This is Question 7. This is based on Night, Chapter 2, Kinematics in One Dimension, and in particular, Section 2.5 on Freefall. First, let's carefully read the question. You drop a rock from the observation deck of the CN Tower. About a half a second later, long before the first rock hits the ground, you drop a second rock. Both rocks are initially released at rest, and air resistance may be neglected. As the two rocks fall, the distance between them A increases, B decreases, or C stays the same.
Okay, so the first ball is dropped, falls some distance, and then the second ball is dropped. Okay, so if you want to know what the distance of, let's say this is ball 1 and this is ball 2. So ball 2 released at t equals 0, let's say, then it will have a distance and it will have some speed 0. The distance will be 1/2 times g times t squared, distance that it falls for ball 2. For ball 1, d1 is equal to distance it travels will be v1 initial times t plus 1/2 g t squared. And so d2 minus d1, the distance between them, is going to be 1/2 gt squared minus the vi1, sorry, 1I t plus 1/2 gt squared. Oops. Okay, so these will cancel, and the absolute value of the distance between them, I should say d1 minus d2, is equal to v1I times t. So basically, since this bottom one starts off with some initial velocity, at that time the second one is dropped, the distance between them will steadily increase by whatever that starting velocity is times time. So they'll get further and further away from each other as they drop.
This is a bit of a tricky one. I think the tendency is to think that since both rocks are accelerating the same amount, the distance between them should stay the same. I think you have to just keep in mind that acceleration and velocity are two different things. So if your velocity is the same, like if you're going the same speed as the car in front of you, then the distance between you will be the same. If the car in front of you is going faster than you are, then it'll get further and further away. Now if the car in front of you is going faster and then you both start speeding up with the same acceleration, it's still going to be going further and further away from you because it started with a higher velocity, and that's what's going on with these rocks. The bottom rock was going faster at first, and then they're both accelerating at the same rate. And so they both keep speeding up, but since the first one was already going faster, it continues to always be going faster. Hope that helps. My name is Jason Harlow, and I approve this message.